When a message is sent from the sender to the receiver, the received message may have errors. That is, the message received and the message sent may not be same. So to detect errors in the data communication, an extra bit called parity bit is added to the message. The parity bit is inserted in the leftmost position of the message and it indicates the parity. So there are two types of parity: even parity and odd parity. Even parity: total number of ones in the data and parity bit together is even. For example, assume that we are using even parity and the data bits are 110, 1010. So here the data bit is given and it is can be written as 1 1 0 1 0 1 0. So the data bit is, it's a 7 bit and the 8th bit is the parity. So it is a even parity. So now we have to find what will be the parity bit. So since it is a even parity, the total number of ones together with the parity bit and the data bit should be even. So here we have 1, 2, 3, 4 ones. So the total number of ones should be even. So already we have 4 ones, so it is even. So the parity bit should be 0. So the total number of ones in the parity and the data bit will be even. So now for 4 ones, so it is a even parity. So the parity bit here for this example is 0. Odd parity: total number of ones in the data and parity bit together is odd. Example, assume that we are using odd parity and the data bits are 110, 1000, 1. So let's write the data bit. So 1 1 0 1 0 0 1. So the number of ones is 1 2 3 4. So it is even. So we need the parity is, it should be odd parity. So together with the parity bit and the data bit, it should be odd parity. So we have here now 4 ones. To make it odd, to put a 1 in the parity bit. Now it will be 5 ones. So it is a odd parity now. Parity bit is helpful in detecting errors during transmission of data. Suppose, for example, if the data that is sent, the message that is sent from the sender is along with the parity is 1 0 0 1 1 0 1 0 and the sender, it follows even parity. So the message sent is this. So suppose in the receiver the message received is 1 0 0 1 0. So this is the message sent from the sender and this is the message received at the receiver. So when you check, so the receiver, after receiving the message, it will check. It will check and see whether it is a even parity, because the sent message is a even parity. So when it check, it sees so 1 2 3, it checks and sees that there is only 3 ones, that is, it is a odd parity. The received message is in odd parity. So it knows that the message received is a error. There is a error in the message. So when it knows that there is an error in the message, it will inform the sender to send the message again. So when the message, suppose if the message is sent again, suppose the receiver receives this message. Okay, so this message is sent and the receiver is now receiving this message. So it will check for the parity, and the parity is even parity only. It is even parity. But the message sent also even parity, but the message, the data present is different. It's not the same. So in this case, the receiver cannot find the error. So this is the disadvantage of using a single parity. So using single parity, this is the disadvantage. So in this case, an additional error detection code is needed. So about that, we will learn in the next video.